In this video, we're going to talk about how to check a multiplication problem using the digital root. One thing I tell the students as we go through the process is really we are just repeating the addition over and over again, as you will see as I demonstrate this process on a few sample problems. However, the technical name is to check it finding the digital root. So the first thing that we would do is we would take each number in the problem and add all of the digits together. So for example, on the multiplicand, 5 plus 9 is 14. Now I'm not finished because I have to keep repeating the addition until I get to a single digit number. So now I'm going to repeat my addition. 1 plus 4 is 5. Now I have my single digit number. I'm going to do the exact same thing on the multiplier. 4 plus 6 is 10. I must repeat the addition. It is not a single digit number, so 1 plus 0 is 1. Now I have my single digit numbers. This is the only place where you are going to multiply when you get to the single digit numbers in the problem. So 5 times 1 is 5. Now we're going to move to the product. In the product, we find its digital root by repeating the addition. 2 plus 7 is 9. 9 plus 1 is 10. 10 plus 4 is 14. That's not a single digit, so repeat the addition. 1 plus 4 is 5. 5 is the digital root for 2,714, and it matches the single digit we found for the answer. So the correct product is 2,714. Let's look at another problem. 4 plus 6 is 10. Repeat the addition. 1 plus 0 is 1. There's my single digit number. On the multiplier, 9 plus 8 is 17. Repeat the addition. 1 plus 7 is 8. They're my single digit numbers, so I multiply them. 1 times 8 is 8. So I'm going to look for the digital root of the product, and it should be 8. 4 plus 5 is 9. 9 plus 0 is 0. 9 plus 0 is 9. And 9 plus 8 is 17. I have to repeat the addition to get to a single digit number. 1 plus 7 is 8. My digital root is 8, and it matches the single digit 8 up at the top. Now, let's look at yet another example. However, before I show this next example, I want to point out one very important fact. Here is something to remember about using the digital root to check an answer to a multiplication problem. It is not foolproof. You will find instances where, even though you are checking correctly using the digital root, you have a seemingly correct answer when it actually is not correct. So let me go back to this problem, and I am going to move it over because I'm going to tell you right now that it is wrong. So let's go through and do the digital root to check it. 3 plus 7 is 10. 10 plus 6 is 16. Repeat the addition. 1 plus 6 is 7. There's my single digit. 8 plus 4 is 12. Repeat the addition. 1 plus 2 is 3. Now that I'm at my single digits, I multiply. 7 times 3 is 21. Now I do not have a single digit, so I have to repeat the addition again. 2 plus 1 is 3. Now I'm finished. I'm looking for 3. So down on the product, 4 plus 5 is 9, plus 1 is 10, plus 2 is 12. Repeat the addition. 1 plus 2 is 3. So seemingly, I do have the correct answer. However, it is not the correct answer. Another thing that I could have done and probably should have done in addition to the digital check is round to find a rough estimate. 376 rounded to the highest place would be 400. 84 rounded to the highest place would be 80. So if I multiply 4 times 8, I would get 32 and add 3 zeros to the end. So my answer should be approximately 32,000. However, my answer is far from 32,000. So I know that I have missed the problem somewhere. So let's go back and see where I've missed the problem. Now I'm just going to back this up just because it's going to be a little bit easier to do that. All right, so I have my original problem, 376 multiplied by 84. 4 times 6 is 24, carry the 2. 4 times 7 is 28, plus 2 is 30, put down the 0, carry the 3. 4 times 3 is 12, plus 3 is 15. So my first lines of work match each other. On the second line of work, I can tell immediately where I have missed my problem. I have to put what some teachers refer to as a placeholder. I personally like to call it a value giver because it is giving the correct value to the number. We are now multiplying in the tens, so we put a 0 to show that you're really not multiplying 8 times 6, but 80 times 6. I did not put my value giver in the original problem. More than likely, this is where I've missed it, and this is a careless mistake that's very often made. 8 times 6 is 48. Put down my 8, carry my 4. 8 times 7 is 56, plus 4 is 60. Put down my 0, carry my 6. 8 times 3 is 24, plus 6 is 30. And sure enough, by comparing the two, this is where I missed it. I did not put my value giver or my placeholder. So now we add 4, 8, 5, 1, 3, 31,584. And if you remember a moment ago, in my rough estimate, my answer should have been approximately 32,000. Well, now it is. But let's go ahead and find it by using the digital root. Now, if you recalled up in our problem, we ended up with a single digit of 3. So now let's see if we end up with that same single digit. Okay. 8 plus 1 is 9. 9 plus 9 more is 18. 18 plus 3 is 21. Now I've got to repeat my addition. 2 plus 1 is 3. Now they match each other. So this is one instance to where even though we did check correctly using our digital roots method, we did not have the correct answer. Let's look at another example. 5 plus 4 is 9. 9 plus 1 is 10. Repeat the addition. 1 plus 0 is 1. There's our single digit. 7 plus 8 is 15. Repeat the addition. 1 plus 5 is 6. Now we multiply our single digits. 1 times 6 is 6. So I'm looking for a single digit of 6. If you notice in this problem, I am just cutting out the steps of actually putting in the plus signs everywhere with the little connector lines. All right, let's check our answer down at the bottom. Now I've been, for the most part, I've been going through adding in order. 4 plus 1 is 5, 5 plus 8 is so on. However, you don't have to do that. So I'm going to do this a little bit easier. 9 plus 1 is 10. 10 plus 16 more is 26. 26 plus 4 is 30. Repeat the addition. 3 plus 0 is 3. My numbers do not match. Therefore, I know I missed my answer. So in this case, I definitely have missed my answer. So I would need to go back, rework the problem, and find where I missed it. I'm going to tell you that I did only miss it in one location. So the minute we find that location, I'm going to go ahead and stop. 8 times 1 is 8. 8 times 4 is 32. Put down my 2. I need to carry my 3, but if you notice, I did not carry my 3. This is where I missed my problem. And that is yet again another very simple yet careless mistake that many students make. They forget to carry the number over to the next column. Now, let's remember that the digital root method is not foolproof. There will be times where you are not going to be able to rely upon it. But once again, it's better to do some sort of check than no check whatsoever. Let's look at this next problem. I have 1 plus 4, which is 5. 5 plus 6, which is 11. Repeat the addition. 1 plus 1 is 2. On the multiplier, 7 plus 3 is 10. Repeat. 1 plus 0 is 1. Now I multiply my single digits. 2 times 1 is 2. So I'm looking for 2. So down on the product, 1, let's do it like this. Here's 6 plus 6 is 12. 12 plus 1 is 13, and 13 plus 8 is 21. Repeat the addition. 2 plus 1 is 3. So it looks like I have missed my problem. Now, one thing also you want to do, I've been going through this rather quickly, and you can also, like anything in math, if you go through it really quickly, you may make even a careless mistake in simple addition. So I'm going to go back and just double check to make sure. 1 plus 4 is 5, 5 plus 6 is 11, and then 1 plus 1 is 2. Okay, that's right. 7 plus 3 is 10, and 1 plus 0 is 1. 2 times 1 is 2. Okay, that's correct. So down here, I'm going to add backwards. 8 plus 6 is 14, 14 plus 6 is 20, and 20 plus 1 is 21. And so when I add, 2 plus 1 is 3. So I did miss the problem. So let's see where I missed the problem. 3 times 6 is 18. Put down the 8. I did carry the 1. 3 times 4 is 12. Plus the 1 is 13. Put down the 3. I did carry my 1. 3 times 1 is 3. Plus 1 is 4. So my first line of work is correct. Now let's go to the second line of work. I have my value giver or placeholder to show I'm now multiplying in the tens. 7 times 6 is 42. Put down the 2, carry the 4, and I did that. 7 times 4 is 28, plus 4 is 32. Put down the 2, carry the 3, and then 7 times 1 is 7, plus 3 is 10. Well, if I have the first line of work correct and the second line of work correct, then the only mistake I must have made is in the addition. So let's see where I missed it in the addition. 8 plus 0 is 8. 3 plus 2 is, I have a 6. Sometimes students accidentally multiply here. That should be a 5. So 3 plus 2 is 5. Next column, or the hundreds column, 4 plus 2 is 6. I have that. And here's my next mistake. I did not get the thousands column correct. 0 plus nothing is 0. And then 1 plus nothing is 1. It looked like, if you notice carefully, I didn't have my columns totally straight, and that's probably my careless mistake by not making my columns as straight as they could be. Now let's go back and redo our digital root. So I know that my number at the top of the problem should be a 2. So now let's look at the product. 1 plus 6 is 7. 7 plus 8 is 15. 15 plus 5 is 20. 2 plus 0 is 2. And now our single digits do match. Now, on this problem, I simply have the problem and the answer itself. I left out the work in the middle. 4 plus 6 is 10. Repeat, addition, 1 plus 0 is 1. There's my single digit. Multiplier, 9 plus 8 is 17. Repeat, addition, 1 plus 7 is 8. There's my single digit. Multiply the single digits. 8 times 1 is 8. Now on the answer, 4 plus 5 is 9. 9 plus 8 basically is 17. Repeat the addition. 1 plus 7 is 8. So they match. That is my correct answer. Now, even though I have the correct answer, I want to show you one other place where using the digital root can be problematic. If someone had the digits 4508 in their answer, but they were in a different order, it would seem like they have the correct answer when in fact they actually don't. Because if I do my digital check, 4 plus 5 is 9, 9 plus 8 is 17, repeat the addition, 1 plus 7 is 8, even though 5,408 is the wrong answer. So this is a really great method to use to give yourself at least one way to check to see if a multiplication problem is correct. However, just remember, it is not foolproof. So good luck with your multiplication.